Woohoo! We're off to Unit 2. So to start off this unit, the first thing I want to do is show you another way to divide. This is called synthetic division. We can also use synthetic division to substitute. So before I show you the synthetic stuff, what I want to do is go back through the long division piece. So when we go to setup, we ask ourselves, what do we multiply x by to make it 2x squared, which would be 2x, then multiply it by the polynomial up front, draw the line, change the signs, cancels out, we get 3x, drop the 9, start over. So then what do we multiply 3x by, or x to get 3x? We need a 3. Multiply it by the polynomial up front, draw a line, change the signs, and we get 3. So then our resulting polynomial would be 2x plus 3 over x plus 2. This was the original way that you learned how to divide polynomials last week. Today we're going to learn a synthetic way. Okay, synthetic of course just means fake. When something is synthetic, it's fake. So this is fake division. And to be honest with you, it's quicker. Like, in fact, you're probably going to see me do this, be like, why didn't you show us this the first time? So now I am going to set this up. I put -2 out in front of the box, and then I take my coefficients and write them to the side, and my setup is going to look like this. So we're going to drop things down, and really, as I go through this piece, I'm just kind of showing you how quickly synthetic division can go. But, moral of the story, notice that my answer is exactly the same as the long division. Boom. And it took a lot less paper. Okay, so what I want to do is I want to go back through that problem. So setup, look at the binomial in the back, specifically the +2. Now I'm going to put it up front in what I call the box, but when I put it in the box, it's going to become -2. Next, I'm going to look at the coefficients in order. So I have 2, 7, 9. Write those next to the box. Give yourself a space, draw a line, and put a bar underneath the 9 spot. So to set up, the first thing we're going to do is drop the leading coefficient, which is 2. Then multiply 2 by the number in the box, which gives me -4. Write that under 7. Then combine in the column. Repeat. 3 times -2 is -6. Draw in the column. Now, I like to work from the back to the front. Okay, so then our answer will end up being 2x plus 3 plus 3 over x plus 2. So let's talk about where I'm getting all those pieces. So the 3 behind the box, that is the remainder. Then I'm going to move over. So I have remainder, constant, x. And if I wanted to keep going, then I would have x squared, then x cubed, and so on and so forth. But that's how I like to kind of think through my setup to write my answer. Okay, so I'd like to do this again. And notice that I'm going to have space so we can write out some steps. Okay, so first thing that I want to do, take a look at the binomial on the back, change its sign when I go to put it in the box. Okay, so that is step 1. Change the sign of the binomial and put it in what I call the box. Then after that, we are going to consider all of the leading coefficients. So I have 3, -1, 5, and -1, but be careful. Notice that there is a missing quadratic term. So we're going to have to make sure we put in a placeholder of 0, just like with long division. So that procedure is going to be the same. So you have to have a number for every single exponent past the biggest one. So I have 3, -1, 0, 5, -1, and then drop a little remainder bar down under the last term. Okay, so I call this step the setup. Okay, so you have to write your coefficients, consider any zeros, then draw your line with the remainder bar. Step 3 is going to be my computation. So the first thing we do is drop down the leading coefficient, which would be 3, underneath a bar. Then multiply the 3 by the box in green. So I have 3 times -2, which is -6. Add in the column, -7, and keep going. -7 times -2 is 14. 14 plus 0 is 14. 14 times -2 is -28, plus 5 is -23. Times -2 is +46, minus 1, 45. Now let's label them. So starting with the 45, I am going to have, pause, rewind. Let's write that down. So for step 3, drop the leading coefficient. Multiply to the box from step 1, add in the columns. then start over. It's always going to be multiply to the box, add in my column, multiply the box, add in my column, multiply the box, add in my column. After that, consider the degrees and then write your solution, which is what I was trying to start doing. But, writing steps is important. So here we go, starting with the 45. 45 is the remainder. Negative 23 is the constant. 14 needs an x. Then I have x squared, then x cubed. Notice that my leading degree is 1 less than the original. So I have 3x cubed minus 7x squared plus 14x minus 23 plus 45 over x plus 2. Let's try that a couple more times. Okay, setup. Binomial on the back is x minus 3, so I have to change the sign, and it's going to become positive 3. That's going to be my box up front. Leading coefficients, 1, negative 2, 3, 1. Don't forget your 0x squared. So I have 1, negative 2, 0, 3, 1. Draw the line, remainder bar. Drop the 1, multiply by 3, 3, add 1, multiply, 3, add, so on and so forth. You might need to pause this video and watch that again. Okay, so don't forget we have remainder, constant, x, x squared, x cubed. So my related polynomial is x cubed plus x squared plus 3x plus 12 plus 37 over x minus 3. For number 4, I think it's a really good idea for you to pause the video and try this one on your own before pressing play. Okay, so 6 is going to the box because it changed signs. There is no missing degree, so I have 1, negative 3, 18. Draw the line of the remainder bar. Drop the 1, multiply and add, multiply and add. Wow, this time we get a remainder of 0. That's okay. So now I have a constant and a bilinear. So my answer is just x plus 3. If you don't have a remainder, you do not need to add it on. The idea of 0 over something is unnecessary. Okay, so we can also use this process to do substitution. It's going to be the exact procedure, just with a different step 4. Notice that my problem is set up. I have x equals 3, and that's not in binomial form. Therefore, you do not change the sign, so it'll stay negative 3. The rest of the process is exactly the same. So I'm going to take my coefficients, 3, negative 4, 6, and negative 12, draw my line in my remainder bar. Drop the 3, multiply, negative 9, add, negative 13, multiply, 39, add, 45, multiply, negative 135, add, negative 147. Now, the cool part of substitution, the remainder is the answer. That's all you need is the answer. Now, could you do this hypothetically the old-fashioned way where you substitute things in? Sure. But in my experience, kids tend to make a lot more mistakes that way.